Alright, imagine you're at your favorite bakery. The smell of fresh bread and pastries fills the air, and the display cases are packed with all sorts of delicious treats. There's a kid, Nia, standing by the counter. She's never seen pastries before, but she wants to guess what each treat is just by looking. She's curious and excited, her eyes wide with wonder. At first she's hilariously off, mixing up croissants and donuts, calling a muffin a cupcake. She's having fun, but she's also learning with each guess. But each time she guesses, the baker gently corrects her. The baker explains the differences, showing her the flaky layers of a croissant, the hole in the middle of a donut, and the chunky top of a muffin. Over time she catches on. Croissants, flaky donuts, holes in the middle, muffins, chunky tops. She starts to recognize these patterns and gets better at identifying each pastry. Nia starts spotting patterns, and before you know it, she's a pastry pro. She can now confidently point out each treat without hesitation. That's kinda how a neural network learns. It starts off clueless, but with guidance and practice, it gets better and better. So, what is a neural network, ELI 5 style? Imagine explaining it to a 5-year-old. Think of it as a computer program inspired by the way our brains work. It's designed to mimic the way we learn and process information. In our heads, we've got billions of tiny cells called neurons, passing signals back and forth. These neurons help us think, learn, and remember. A neural network copies this idea. It's a digital version of our brain's network of neurons. It's got its own digital neurons, but instead of sending electrical signals, they pass numbers. Lots and lots of numbers. These numbers represent different pieces of information. Now, let's say you want to teach a robot to spot cats in photos. This is where the magic of neural networks really shines. You show it a cat picture. The robot takes in this image and starts processing it. This image goes through a web of those digital neurons. Each layer of neurons processes the image in a different way. The first layer looks at simple stuff, edges, colors, textures. It breaks down the image into basic components. The next layer combines those into shapes, maybe whiskers or ear points. It starts to recognize more complex features. Deeper layers start piecing together the idea of catness. It begins to understand what makes a cat a cat. At first, the robot is basically Nia on day one, totally clueless. It makes a lot of mistakes. It might call a dog a cat or confuse a cat with a loaf of bread. It's still learning and figuring things out, but every time it gets it wrong, you tell it, nope, that's a dog. This feedback is crucial for its learning process. And each time, the network updates thousands of tiny numbers and connections inside. Just a little nudge here, a little tweak there. These adjustments help it improve. This process is called training. It's like a coach training a team, refining their skills with each practice session. Think of it as a recipe with hundreds of secret ingredients. Each ingredient plays a role in the final dish. Each batch, the more photos you feed it, the more the recipe gets tweaked. The network learns from each new example. Eventually, the neural network gets so sharp it can find cats in blurry photos, upside-down photos, even cats in shark costumes riding Roombas. It becomes incredibly adept at recognizing cats in all sorts of situations. Here's the wild part. Nobody ever tells the network, hey, a cat has pointy ears and whiskers. It figures this out on its own. You just give it tons of examples, and it figures out the patterns on its own. It learns from the data you provide. It learns just by doing, like a super curious kid. It experiments, makes mistakes, and gradually gets better. So to sum it up, a neural network is like a child learning by example. It takes in information, processes it, and improves over time. It takes in raw data, like pixels or sounds, sends it through layers of tiny decisions, and finally spits out an answer. Each layer refines the information a bit more. With practice, it gets better and smarter. The more data it processes, the more accurate it becomes. That's the magic of neural networks. They don't just crunch numbers, they learn, grow, and sometimes totally surprise us with their capabilities. They can recognize patterns, make decisions, and even predict outcomes. It's like watching a child have a light bulb moment. They don't just crunch numbers, they learn, grow, and sometimes totally surprise us. And that's the incredible journey of neural networks.